All right, let's just dive right in. Have you ever stopped and wondered how your computer or your phone manages to sift through just mountains of information almost instantly? Finding that one specific email out of thousands, or loading a web page with a million different parts in like the blink of an eye? Okay, let's pull back the curtain on this hidden world of digital organization.
Seriously, just think about it for a second. Your phone could have tens of thousands of photos on it, but when you type in a search for beach, the results just pop up in seconds. How is that even possible? Well, it's not magic, not at all. It's actually a brilliant system of organization, and we're going to break it all down today.
So, to really get this, let's start by picturing the total opposite of a good system. Let's imagine what your computer's data would look like with zero structure. I mean, it would be absolute chaos.
And that's the core problem, right? All that data, your photos, your songs, your documents, it's like a million books just dumped in a giant pile. Without some kind of system, trying to find just one specific book or one piece of data would take forever. The computer would be painfully, uselessly slow. So how do we fix this mess? Well, computer scientists basically use two main tools. First, a really precise set of instructions, which we can think of as a recipe. And second, different ways to organize all that data, which you can just imagine as different kinds of bookshelves. First up, the recipe. In the tech world, this is called an algorithm. Our source material puts it perfectly. It's a sequence of definite and effective instructions. Really, it's just a clear, step-by-step plan for doing something, whether that's sorting a list of names or finding the fastest route on a map. Okay, so we have our recipe. Now we need a place to put all our books. This is a data structure. It's literally just the way we decide to organize or structure our data. And the kind of bookshelf you pick completely changes how well your recipe, your algorithm, is going to work.
And this is where it gets super interesting, because there isn't just one type of bookshelf. Oh no, there are a ton of them, and each one has its own unique strengths and weaknesses. So let's check out a few of the most common ones.
So the simplest system is called an array. Just picture one long bookshelf where every single slot has a number, starting from 0. The data is stored in what's called contiguous memory locations, basically one thing right after the other. Now, this is awesome if you know the exact slot number you need. You can go right to it instantly. But adding or removing a book from the middle, it's a huge pain. You'd have to shift hundreds of other books just to make one little space. Now for a totally different approach, the linked list. Here, the books aren't in any particular order on the shelf. Instead, each book has a pointer. Think of it like a little sticky note that tells you the exact location of the next book in the series. Now, finding a book in the middle can be slow because you have to start at the beginning and follow the whole chain of notes. But inserting a new book is incredibly easy. You just change 2 of those little notes and it's slotted right in. No heavy lifting required. So here's the bottom line. It's all about the trade-off. An array is fast and super efficient for something that doesn't change much, like the settings menu in an app. But a linked list? It's perfect for something dynamic, like your music playlist or a social media feed, where you're constantly adding and reordering stuff. It all comes down to picking the right tool for the job. Okay, so let's see how these basic ideas can be used to build some very specialized but really common systems. And believe it or not, you use these next 2 concepts every single day without even thinking about it. Stacks and queues. A stack works on a really simple principle. Last in, first out, or LIFO for short. Think of a stack of plates or a book return bin at the library. The last book you chuck on top is going to be the first one somebody grabs. A perfect example of this in the digital world is your web browser's back button. Each page you visit gets pushed onto the stack. When you hit back, the last page you visited gets popped right off the top. Simple as that. And a queue is, well, it's the exact opposite. It follows the first in, first out principle, or FIFO. The source material nails the analogy. It's just like a queue of customers at a counter. The first person who gets in line is the first person to get served. Your printer uses a queue. The first document you tell it to print is the first one that comes out of the machine. Makes sense, right? Okay, so we have all these different shelving systems, right? Each with its own pros and cons. But how do we actually, scientifically measure which one is faster? Especially as our library gets bigger and bigger and bigger. For that, we need what I like to call a slowness scale. Now, in computer science, this scale is called time complexity, and we use a special kind of shorthand to grade it called Big O notation. I know it sounds intimidating, but don't let the names scare you. It's just a simple way to answer one question. If I double the number of books, does it take twice as long to find one, or does it take way, way longer? It's basically a report card for efficiency. And this is where it gets wild. Look at just how dramatically performance can change. An algorithm with a grade of O of log n is unbelievably fast. I mean, even with 100,000 books, it might only take 17 steps to find what you want. But an ON squared algorithm, that's one of those way, way longer ones, it gets slow so fast. With that same 100,000 books, it would take 10 billion steps. And an exponential one, forget about it. It becomes impossible almost instantly. So you see, the big point here is that none of this is just abstract, nerdy theory. This invisible world of organization is what makes the technology you use every single day actually work. It's the difference between something that feels like magic and something that's just frustrating. Every single time you search for a song, there's an efficient data structure and algorithm finding it for you in a flash. When your social media feed loads new posts, it's probably using a queue. When you get driving directions from a map app, that's a sophisticated algorithm finding the shortest path. This stuff is absolutely everywhere. And this quote just says it all. This is the big takeaway. The real art of building great software isn't just about typing code, it's about deeply understanding these trade-offs and picking the most efficient way to organize information to solve a specific problem. So I'll leave you with a little thought experiment. The next time an app on your phone feels sluggish, or it takes just a little too long to search for something, think back to our digital library. Ask yourself, what kind of bookshelf do you think it's using? And more importantly, what might have been a better choice? Thanks for watching.